Hi there. For this video, we are tasked to find the smallest possible value of n given this inequality out here. So we have m over n is between 12 over 2015 and 13 over 2016, where m and n are positive integers. So before we solve this one, feel free to pause the video so that you may try this one first on your own. Okay, so let's start. So first, we take note that if we are given a over b is less than c over d, and we take their reciprocals, take note that the inequality out here would reverse or flip. Indeed, if we have this example, so let's have 2 is less than 4, we know that if we take their reciprocals, clearly 1/2 is greater than 1 over 4, since in decimals 1/2 is equal to 0.5 and 1/4 is equal to 0.25. So clearly 0.5 is larger than 0.25. So this idea is what we'll be using in answering this problem, and we apply it out here. So we copy that one, and if we take the reciprocals, we have 2015 over 12 and 2016 over 13 and n over m. Again, what happens to the sign is that we flip them out. So far so good. So I hope it's still understandable. Next thing we do is we convert these improper fractions into mixed numbers or mixed fractions. So if you don't know how, I would probably link a video on how to do that around somewhere in this video. So continuing, so to do that, we have 12 divided by 2015 out here. So let's start. So we start with here with 1, and this would give us 8, bring down the 1. Then we have here is 6, since 12 times 6 is 72. Subtract these two and we get 9, bring down the 5. And we have here 7, 12 times 7 would be 84. Subtract these two and we get 11. So our remainder is 11. So given this, we know that we have converted this improper fraction into 167 and 11 over 12. So this is its mixed fraction form. So we have this. Indeed, so we have here a whole number part and a fractional part. We do the same for 2016 over 13. So we have here 13 divided 2016 there. So we have 1 out here, 13, subtract these two, we get 7, bring down the 1. And for this one we have 5, since 13 times 5 is 65. Subtract these two, we get 6, bring down the 6, and again we'll be using 5 out here since 13 times 5 is 65. Subtract and we get 1. So this would become 155 and 1 over 30. So this would be like that. So this is what we have so far. And given this, we can actually obtain the smallest possible value for n already. First, take note that m is a positive integer. Then we know that m ranges from 1, 2, 3, and so on. Should be positive integer. And when will n be the least, or when will n be at its smallest possible value? Well, the answer to that is if m is equal to 1. And why is that? Well, suppose if we take 10, we can write this as 10 over 1, 20 over 2, 30 over 3, and so on. So as we can see out here, at m is equal to 1, n is equal to 10, which is the smallest among 10, 20, and 30. So in other words, if m is equal to 1, then n would be at its smallest possible value. Since the idea is like it is at its lowest term if m is equal to 1. So let's clear this one out. So if m is equal to 1, what is the smallest possible value of n that we could take out here? Well, since we have 155 out here, after 155, the next is 156. So therefore, at m equals 1, the smallest possible value for n in this inequality is n equals 156. And this satisfies the inequality since 156 is between 155 and 167 out here. So therefore, indeed, this out here is our final answer. And we had found the smallest possible value for n. So did you got that one correctly? I hope you did. The key again is this part out here. So yeah, I hope you enjoyed and learned a lot from this one. Please don't hesitate to comment down below if you have another solution or even another answer if probably I'm wrong out here. And if you have questions, you can also comment that one down below. So yeah, that's it, and that's all for this video.